Welcome to the switches. So let's talk a little bit about your switches. You have two main kinds of switches. One are push button switches, which would be these guys here, and dip switches, which are these. And let me show you what they look like. You're going to need 3 of these and 4 of these. This here is your push button switch. These are rattling around. I just plugged it into the phone so you can see what it looked like. You're going to need to get these plus, according to this, you're going to need 4 330 and 12 1K ohm resistors. So we know from this one here, the 330s are orange, brown, gold. These we know from this part right here is going to be brown, black, red, gold. So you're going to need 12 1Ks, 4 330s, 3 of these switches over here, 3 of your dip switches, and 4 of the push buttons. So go ahead and get them. Talk about the schematic here. These are switches. So what's going on here is we have 5 volts are going to get connected all to one side. On the other side, when you close the switch, you're going to bring 5 volts to here. This here resistor is, imagine it like a rubber band. It's going to get stretched and it's going to get pulled up to stretched out to 5 volts. And then when you open this switch, the 5 volts is going to disappear, and this rubber band slash resistor is going to pull it back down to the ground. These act as rubber bands, pulling them down to the ground. It gently pulls it in whatever direction it's connected. So in this case, these are connected to the ground. Also, to bring something back up, these dots here mean that they're connected. So this node is connected to this wire right here. If now you see this bend right here, that's the final connection. So you generally don't want to put junctions on them. I put a junction on this just because my software got carried away. Now you also notice that there's something wrong here. On the next schematic you'll see this corrected. So these are pins 1 through 4, and this here turns out to be 5, 6, 7, 8. Just don't want you to get too confused here. This right here is where you're going to plug in and get the output of the switch, just like the input of the LED. So you could wire this up directly to here, and when you turn the switch on, the LED would work. And we're going to do that to test these anyways. Push button switches are the same thing, except these are momentary. These here lock. To show you this here, you'll hear the click or not. In the phone you can't quite hear it. But these here are push buttons, and they're the detent style. Now let's do the build. Got our parts. We got 3 of the dip switches and 4 of the push button switches. Plus, remember, you saved the little wire cuttings from your LEDs. You're going to need a pile of those to do this. If you didn't, then you'll need to strip some wire and make a bunch of little bends. I'm going to look at my old board here for the first one, original prototype, to see where to put these. Alright, so the first place we're going to put the dip switch, the first dip switch, is going to be at 25. So it's going to go across. And remember to push down gently but firmly. Make sure it's seated all the way in, and you're going to push down and it should snap in. You should feel it pop in there. The next one is going to go at 30, and the final one is at 35. Okay. And now we're going to put our push button switches. The push button switches are going to go at in the middle of C. At the push button switches are going to go at we're going to start backwards here. So at C, all of these are going to go in the C row. 25 to 23, 20 to 18, 15 to 13 in the C, and 10 to 8 in the C. Now I'm going to take advantage of a connection here, which actually we're going to remember in the schematic. Here we go. Remember in the schematic, we need to connect all of these. So we're going to use those wires that we saved from the LEDs to make those sorts of connections. So then if you cut them in half, it works out pretty good. Pull 3 aside. So we got all our switches plugged in. I put one in already. I'm going to show you. We just fold them in half. You will definitely need to cut that shorter. So that's a nice length, and you can fold these by hand. And be careful not to poke yourself. I want to fold a pile of these. This here turns out to be one of the wires from this diode here. I recommend you don't use it. So I'm going to put this off to the side. Find a couple more. See, being magnetic does help sometimes. Alright, so cut these a bit. I'm going to cut these a little bit shorter. Remember, everything needs to be 3/8 of an inch. If it's longer than 3/8, you're going to have unhappiness. And now you can see why I told you it's going to take you about 12 hours to do this. Not hard, it's just lots of stuff to do. Okay, so I'm going to plug these in. Got some parts more that get picked up from the magnet. Close that a little bit. Put that in here. Here to here. Okay. So that's 3 there. And then how did I do that? So I did here. Here. Now remember, position 4, 24 and 34 do not have a connection. You'll see that if you look a little bit closer. I need one more here. And I'm going to put this one this way. You can do this any which way you want. Just make sure you get everybody connected. And you're also going to be testing these to make sure they're all connected. So and remember I told you to save 3. Turns out you needed to save 2, but I need 1 more here anyways. So make sure you shake out your wires, shake your board out a little bit so you don't have any wires stuck in the wrong place, because wires stuck in the wrong place tend to short out and cause unhappiness. And that unhappiness comes in the form of the little smoke genie, as you've already heard about. Alright, so I'm going to fold this down here, make this a little bit longer. That's going to skip over a little bit. Okay. So, using the tip of the needle nose pliers as a bending jig, and then cutting it shorter to the correct length. Okay. So, how did I do that? I did that like this. So what's next? So we got 25 through 29, or 28, 25, 26, 27, 28, hooked up with jumpers, see? Hooked up with jumpers, hopped over one, connect to here, and then stitched them again, hopped over one, and then did these. Okay. So what's next is we got to hook this up to the 5 volts. So we're going to need a 5 volt jumper. It doesn't matter where you connect to this as long as you get one of them connected. And so to do this one here we need a 9. That's connected, so all of these here are going to get powered up. Now the next thing we're going to do is we're going to take the 1K ohm resistors as shown in the schematic here. You see, lots of 1Ks here. So we're going to connect all these up. Now something you'll notice on some of these breadboards, the numbers are backwards, or numbers are in different directions depending on which way you go. I always wondered about that. But that's half the fun of this. Alright, so I'm going to roll these up. I just rolled them up. Cut the 1Ks. Cut them medium long. Remember, you can always cut them shorter. You cannot make them longer. If you cut them too short, you're going to need to get replacement parts. Resistors, again, do not have a polarity, so it does not matter which way you put these in. I'm just folding these over. Okay. You need 12 of these. I just cut a whole pile of them, I didn't even count. So that's 4. Next nibble. Alright, so I'm going to have 12 here. How long are you going to make these? You're going to make them 3/8 of an inch. Start plugging these in. The first one is going to go to 25. So we're going to do all of these pins right here. You see the pins right there? So we're going to skip right there. We're going to skip right there. So 29 is going to get skipped, and 34 is going to get skipped. So we need to cut these a bit shorter. Make them all happy. We're going to make them 3/8 of an inch. Make them longer. They will short out. Make them too short, you won't get a connection. If you won't get a connection, you're going to be scratching your head trying to figure out what's wrong. So 3/8 of an inch, folks. 3/8 of an inch. When in doubt, lay it on the breadboard and get it to number 4. So just as a demonstration here, this is on the 50. So that's a little bit on the short side. Make them 53. All right. Three-eighths of an inch. Every one gets every switch here gets a resistor. Make sure you do that. Afraid to go home. There we go. So once you get all this done and your breadboard's all working, now you can begin to have a lot more fun. I know this is tedious, but this will actually, all of this will give you confidence when doing your circuit building. You'll have good results. And logic design is one of the, I don't want to call it the easy class, but it's not the most complicated class. The math and the material is not that difficult. There's a lot of things you got to learn and do, but as I tell everybody, just do it. It will serve you well. A lot of really important concepts in the class that will take care of you throughout. Alright, so these are done. So since these are done, let me get my handy dandy testing wire here, and we're going to turn this on. Now I'm going to turn everybody off first. So position 0, or excuse me, these are off and up is on. See, it says on right there. You know, it says on. So that's the on. So when you slide them this way, they will turn them on. This up to, it doesn't matter which one, I'm picking that one. Just because the wire's out of the way. And so not working. Remember my telling you need to make sure you get the wires plugged in correctly and have them the correct length. And remember I said, oh well, that looks pretty good, and it was working okay, but now that I moved everything around a bit, it's not working that well. So I don't have my light on. See, I have the switch on, but I don't have my light on, and there's the problem. So I leave my mistakes in there so you can see them and learn from them. Yeah, I've been doing this for a really long time, and yeah, I still make mistakes, but more importantly, I'm making the mistakes sometimes on purpose. So you can see what happens when you don't have a good connection. That's going to be a real bear. You're not going to have fun finding that. So make sure you get your wires in the correct length and plug them in. You can see that this here doesn't look quite well folded in. Let me move this here. You see how that doesn't look good. So turn the power off, and see that wire is actually too short. So we're going to make this correct length. Okay, so like I said, make sure it's 3/8 of an inch long, and now you see why it must be 3/8 of an inch long. So, not exactly pretty, but it works. Alright, so definitely please learn from that one little mistake. So let's demonstrate the LED works. There we go. And I am going to plug this in. All these should be off. So one way we could check things is I'm over here on this side here, and I'm touching the shoulder of the part. So yes, I know I got each one of these has power. I told you I was touching all the shoulders, and now I want to plug in here. Okay, now let's turn on them. There you go. So when I turn them on, now something to keep in mind. Each one of these is going to be drawing some power from your battery, so keep them turned off unless you actually need them. Right. And you'll notice that I didn't pay attention to which way I put the resistors, because resistors don't matter which direction they go in. Alright, so now should be nothing there, nothing here. And done. Alright, congratulations. And now I'm going to turn these off. Okay, so that part of the circuit is done. Now we need to wire these up. So to wire these up, we need to hook up the resistors and the ground, or resistors and power. The resistors are going to get connected to ground, and then 5 volts will go on the other side of the switch. So you need 4 330s. Alright, so here's a 330, which is an orange brown, Okay. There's a little bit on the short side. This one's a little bit on the short side. Okay, and one more here. Okay, how long are you going to cut them? 3/8 of an inch. How long is 3/8 of an inch? It's 0.375, so that makes it about 3.5 holes. Okay, so now what we're going to do is we're going to go from the minus ground to that pin right to this one here. Actually, we're going to do it we're going to do it on the 10s. So first one's going to be on the diagonal a little bit. You can put that one in pin 1. The rest of these are going to go in, the minus to 8A, and then the others are going to go from the minus to 12B, 13B. Move these out of the way a little bit, make it easy for you to put them in. I'm gently holding it on the body and plugging it in. Remember, if you squeeze too hard, these will crunch up. And you won't enjoy that. Okay, so there we go. Alright, so this one's done because it's borrowing power from the first switch. But these three need to get wired up. So those are 9s. You need 3. Three 9s. Okay. And so this is going to go in 10A to the power, 5 volt, 15A power, and 20A power. Okay, there we go. Now, let's test them. Now remember, turn your power off, power is on, and I'll plug that in here. Ooh, what's going on? Well, what's wrong here? See what's wrong? What's wrong is I plugged the wire into the wrong spot. So I have a 330 going to the ground, and I'm on the minus side over here. So I need to be on the plus side of the LED. And there we go. Alright, your pickup point is on the resistor for the switches. On the LEDs, it's not the resistor. Okay, so not bad. So very good, congratulations. You're about halfway through. And now the next thing we're going to do is the logic probe. See you shortly.